How are you, my friends? This video is presenting 8 old exams questions related to the complex zeros of polynomial functions, lecture 38 from the algebra course. Question number 1, we need to list all the zeros and their multiplicities. See, if you look at the first one, we need to factor a little more here, x squared plus 25. This one we need to factor, this trinomial, this is already factored, that's linear inside. So just make a table here. So the first one, x squared plus 25 will be x minus 5i, x plus 5i, each one cubed, you see? So the zeros are 0, multiplicity 1, and then 6, multiplicity 8. This minus 10 is the leading coefficient, so we don't count it in the zeros. We have 5i minus 5i. In the second one here, 55 is the leading coefficient, so we have 0 repeated 3 times. Here we factor x minus 1, x plus 2, each one power 5. So 1 and minus 2 is power 5. And there's here, we take this one is equal to 0, it becomes 2 minus square root of 3, repeated 2 times. Now question 2 says, if 3i is a 0 of the function x power 4 minus x cubed plus 10x squared minus 9x plus 9, find the number of x-intercepts. We know this is a polynomial function of degree 4. We checked the coefficients, 1, minus 1, 10, minus 9, 9. All of them are real, yes. So since 3i is a 0, we can conclude directly that the conjugate minus 3i is also a 0. Only if we have real coefficients. So I put here the coefficients by synthetic, 1 minus 1, 10 minus 9, 9. I divide by 3i. I know 3i is a 0. So bring the 1 down, multiply by 3i, add, multiply by 3i until you get 0. Then I divide by the conjugate minus 3i. Also, I get the remainder 0. So I take the quotient here, x squared minus x plus 1. Discriminant here is minus 3. You know, b squared minus 4ac. Discriminant is minus 3. So we have 4 complex zeros. Unfortunately, now the number of x-intercept will be the number of real zeros, which is 0. So this graph of this function here will not cut the x-axis. Find a polynomial capital T of degree 5 that has integer coefficients. The 0 is half, minus 1 of multiplicity 2, and minus I. The leading coefficient should be 4. So I start to build the function here. See, we know the real coefficients, it says in the question, so minus I is a 0, then the conjugate, which is I, is another 0. So I put here the function t, a, I have to put the coefficient a, x minus c1, x minus c2 squared. Why c2 squared? Because the second 0 here is multiplicity 2. Then x minus I, x plus I. See, I multiply this by a sum of 2 squares. This one, x squared plus 2x plus 1, and this is x minus half. Then I put a. Now look at the question here. In the given, it says the leading coefficient should be 4, the leading. So a 4 here. So 4, you multiply 4 times. See that one? 4 times the x is 4x, 4 times the half, you see, is minus 2. Then I multiply this and this. You can multiply anything you like. And remember here, x plus I, x minus I will be x squared plus 1. You can multiply this and this first. It's up to you. I multiplied this and this. You get all this. Please check it. X squared plus 2, 1 here. Then I multiply again, term by term, until you get capital T is 4x5 plus 6x to the power 4, etc., etc. Please check the numbers to make sure you understand it. Find the product of the complex zeros. So this is a degree 5 here. So we know there are 5 zeros, maybe repeated, maybe real, maybe complex, maybe rational, maybe irrational. We need to find the complex zeros and then multiply them first, A. And the B, we need the number of real zeros. It happened that we can factor this function, you see, easily. Just use grouping. The first two terms take x cubed, so x squared plus 1. This one take 8 out, so we have x squared plus 1, x cubed plus 8. Now this one you can do sum of two cubes. Remember in the sum of two cubes. So this one, x squared plus 1 becomes x plus I, x minus I. This one becomes x plus 2. And then here we have x squared minus 2x plus 4. We cannot factor this, so we use quadratic formula. Just quadratic formula. A is 1, B is minus 2, C is 4. And then we find all zeros on the other side. We use quadratic formula for this. We get x equals 1 plus or minus square root of 3i. So look at the zeros now. Minus 2, I, minus I, 1 plus square root of 3i, 1 minus square root of 3i. Let's answer part A. Find the product of the complex. So I multiply I times minus I times this times this. See this one? 1 plus 3. So the whole answer is 4. Find the number of real zeros. It's only 1. It means one x-intercept there. This is a nice question. Look at why it's nice. Multiple choice. And we need the type of the zeros. The zeros of x to the power 4 plus 4x squared minus 45 are for rational, for irrational, for complex, etc. So you have to read it. So let's look, we have to find the zeros. Also, it happened here that we can use trinomial factoring. See, x squared minus 5x squared plus 9. If you multiply, you get x to the power 4 plus 4x squared minus 45. Now this one, difference, real numbers here, x minus square root of 5, x plus square root of 5. This one, x minus 3i, x plus 3i. So two complex, two real. Now these real are irrational. Look at all the zeros. Square root of 5, minus square root of 5, 3i, minus 3i. So where is the choice where we have two irrationals and two complex? See, two irrationals and two complex, so the answer is D. Just a little note here, please. If you cannot factor it, suppose I change the numbers here and put 40 or minus 2 or whatever, then you have to use rational zeros P over Q. Question number 6, find the polynomial P of x of degree 3 that has integer coefficients and zeros half and 3 minus I. Integer coefficients also, that means they are real. So 3 minus I is a 0. Then we can conclude that the conjugate 3 plus I is another 0. So I try to build the function x minus c1, x minus c2, x minus c3. And here I have to be smart in multiplication. You see x minus 3 plus I, x minus 3 minus I. It becomes, this is the sum of two squares, x minus 3 squared plus 1. And then leave x minus half now. Look here, it will be x squared minus 6x plus 9. You see that one? Perfect. Plus 1, so it becomes here 10. Then I multiply this and this. Now in the question here, there's a condition. It says integer coefficients. See, all the coefficients should be integer here. So 5 is integer, 13 is integer, 13 over 2 is rational. So I put A2 here, and then I multiply everything by 2. So this now I get all the coefficients here are integers. That's the answer. Find the lowest degree of a polynomial with real coefficients having the zeros minus 6, 3 of multiplicity 2, 4 plus I, 7 minus I. So we need here only the degree. Is it 9, 8, 7, 6, or 5? So just go slowly and see. Now minus 6 is a 0. See, it says here minus 6 is a 0, so x plus 6 is a factor. That's 1 in the degree. 3 is a 0 of multiplicity 2. You can say x minus 3 all squared. Polynomial with real coefficients, that means 4 plus I 0, given, see given. 4 minus I is also a 0, so we have two factors there. And then 7 minus I is a 0 given. So the conjugate 7 plus I is also a 0. So let's find the degree. See here 1, here repeated 2. And here we have 1 and 1, 2. And here 2. So the answer degree is 7. C is the answer. If 2 is a 0 of this polynomial function of degree 6, this is not easy function at all. We need to find the product of the non-rational zeros. We know the rational zeros. Rational zeros, P over Q, like half, like 5, like -1, like 3 over 7, -1 over 6, also 10 and 15. So we need to find all the non-rational. So maybe they are irrational or they are complex, and then multiply all of them. So 2 is a 0. So we can try synthetic division by 2. Remember, 2 is a real number. So we cannot say -2 is a 0. That's a big mistake. Maybe -2 is another 0, but it is not for sure. Yes, let's go. So 2 is a 0. Make sure I put all the coefficients here. Nothing is missing there. 1 -4, 6 -8. See, there's a missing here. Wow. -8, there's a missing square. So I put 0, 32, -32. So I try to, because it says given 2 is a 0. So 1 comes down. I do synthetic and I know for sure, and the remainder is 0. So 1, and then multiply by 1 here is -2, multiply by 2 until you get the remainder 0. You can check the numbers, please. Then I divide by 2 again, because I know if there is a 0, maybe, not for sure, it is repeated. Now, put 1 goes down here, 1, 2, 0. And then 2 times 0 is 0, that's 2. So 1, 0, 2, 0, -8, the remainder 0. Yes, 2 is a 0. 2 is a 0 of multiplicity 2. So let's take the quotient now. We still have 4 because we have 6 zeros there. X power 4 plus 2x squared minus 8. You can use factoring trinomial this one. Yes, we can factor, I think. Factor the quotient. X power 4 plus 2x, make sure, minus 8, yes. So you can factor it as x squared minus 2, x squared plus 4. Let's factor this more real numbers, x minus square root of 2, x plus square root of 2. And this one, x squared plus 4, is a complex. So x minus 2i, x plus 2i. Now let's see all the zeros. There are 6 zeros. We have 2 repeated 2 times. So this is rational. We have square root of 2 minus square root of 2. These are irrationals. 2i minus 2i. So the product of non-rationals takes square root of 2 minus square root of 2. 2i minus 2i. Be careful here. The first two, the product is minus 4. Minus 4. And here we have minus 4i squared. I squared is minus 1. So the whole answer is minus 8. Now these are the answers of these 8 questions. For other examples, similar examples and many examples, please you can go and check the video on Algebra Course Lecture 38. The course, the lecture itself, 38. Complex zeros of polynomial functions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you very much.